All right, so here, this is all about implicants, prime implicants, and essential prime implicants. So before we start, the first part is, the most important part, is to have the definitions. The definitions for these are very, very important, and it's very important that you get them, that you understand them very well. So the first one is implicant, which is a term of a Boolean expression, sum of the parts, which cannot contain a zero. So when you have your Boolean expression, there's an example here, but the Boolean expression, so a term of the Boolean expression, it could be a, b plus c, d. This here is a term, and this is also a term. So anything that appears, that has a possibility to appear in a Boolean expression is considered an implicant, and it cannot contain a zero in that group. So if we look at this example here, if we have a group that's here, this cannot be an implicant as it contains a zero term. However, if it is this, that is an implicant. The next definition is a prime implicant. This is the largest group of ones that do not include a zero. So when we look at this K-map here, we can say, for example, we can take this group here of 2, and yes, so let's take the boxes here. Is it an implicant? Yes. Why? It does not include any zeros in the group. If it was this group here, this would not be an implicant. However, is this a prime implicant? No. Why? Because it's not the biggest possible group that it can have in its current position, because it can become 4. Now, is this a prime implicant? Yes. Can it be any bigger? No. So the next stage after this is 8, 2 to the power of 3. There's no possibility for this group to get larger. Now, the last definition that you need to know is an essential prime implicant. This is a prime implicant that includes a min term that no other group of ones covers. So no other prime implicant contains this digit. So say, for example, you have this group here, and no other prime implicant contains these. There might be a group here, there might be a group here, might be a group here, but since no other group contains these ones here, that makes this 4 a prime implicant. Now I'll show you how this works with this practice example, which is in the lecture slides. I think it's lecture 23. So I've already worked it out here, and you can, this is being a bit much with all the colors, but it's just to visualize it. So I like to do it where you kind of have it step by step, or term by term approach. So for the first one, it's A, C complement, D complement. And so I've taken the liberty of circling this. So this is one, the blue one here, these two terms here. Now, like earlier, we can determine this is an implicant as it is a group of ones that contains no zeros, but it is not a prime implicant as it does not include the biggest group of 4. So that's an implicant. Next, we have BD. BD is the yellow group here. And we see that it does include a 1, however, it also includes 3 zeros. Due to the presence of zeros, it is not an implicant, so it cannot be included in the Boolean expression. Next, we have A, B, C, D all complemented, and this corresponds to this 1 up here, the top left corner. Since it is a group that contains a 1 and no zeros, it is an implicant. However, is it a prime implicant? No. This can be expanded to be a group like this, which would be a group of 2 ones, which is larger than 1. Thus, it is not a prime implicant. In a situation where there is no 1 here or any 1 here, then this will become a prime implicant. However, it is not the largest possible combination in its current state. Next, we have A, C complement. This is this green group here of 4 terms. It is not possible for this group to get bigger, and it does not include any zeros, and thus it is a prime implicant. Lastly, we have this term here, A complement, C, D complement. This is the red group here. This includes two ones with no zeros, thus it is an implicant. And it also is also a prime implicant, as it cannot be larger. It can have a group like this, which is a possibility. However, that is also only two ones, and they can only combine to the power of or sorry, one to the power, two to the power of this. This is how they combine. So they have to be groups according to the power of 2, or 2 to the power of x, or whatever. So it can't have a group of 3. And that is everything.